In this session, we are going to model the structural elements and walls. After the foundation modeling, let us continue to model the upper structure. In this session, we are going to construct the structural columns and RC walls in B1F. First, let me demonstrate how to construct the structural columns in the B1F. We can directly duplicate the columns from the red foundation. We need to first click the drawing area so that we can edit the properties of the B1 view. In the Properties palette, edit Primary Range in the Extend field. After we click the Edit button, the View Range window will pop up. In this pop-up window, let us set the offset values to -10 in both bottom of primary range and view depth of level. The next step is to select all the objects in the drawing area and then select Filters in the Modify tab. Uncheck all the items except Structural column. Click the Copy to Clipboard tool and then select the Path tool with the option Align to selected labels. Let us select B1F as our target for duplicating the columns. However, we need to adjust the top level of these columns to 1F in the Properties palette. As for base offset and top offset, we set their values to zeros. Now we have finished all the structural columns of B1F. The next step is to construct the wall components. We can identify in the underlay that there are two types of walls in B1F. The walls around both shaft and elevator are brick walls, and others are RC walls. Let me show you how to construct the top row of the walls as a demonstration for wall modeling. You can follow the same procedure to finish the remaining walls by yourself. First, click the Architecture tab and select the drop-down list of Wall Architectural tool. In the Properties palette, select Basic RC Wall 20 cm. Choose Finish Face Exterior in Location Line and set Base Constraint to B1, Top Constraint to 1F. As for base offset and top offset, we retain their value as zeros. In addition to these parameters, it is worth noting that we need to uncheck Chain in the Options bar. The next step is to construct the walls according to the underlay. By clicking the two endpoints of a wall from the underlay, we can create a new wall. The rest of the walls can be constructed by the same procedure. However, you should develop a habit to follow a fixed sequence so you won't miss out any walls. Let us construct these walls from left to right and from top to bottom. We should also be aware that several walls have different geometry properties. For example, the thickness of the side walls of the stairs is different from that of others, and the wall height of reservoirs and stair towers are also different. According to the notations on the underlay, the height of the reservoir is 195 centimeters, So we should change its base constraint to B1F, top constraint to unconnected, and then set the unconnected height to 195 centimeters. The walls of the stair tower are more complicated because some of them do not connect to the B1 floor. We need to apply the Edit Profile tool under the Modify tab and then create a section view to edit the profile of the wall. After constructing the walls in B1F, we can move on to construct beams and slabs for 1F. Let us start with beams. In the project browser, open the 1F plan view in Floor Plans. Before constructing the beams for 1F, we must first edit the view range in the Properties palette to make the columns in B1F visible so we can identify the connections between columns and beams. Because in the 1F plan view, the elements located in B1F are not visible by default. We can input an appropriate value such as -10 until the columns in B1F can be identified in the 1F plan view. The procedure of constructing beam components is similar to that of constructing foundation beams. Since the beam types are different between the two cases, we must select the correct beam type during the modeling. From the underlay, we can only identify the width of the beam, but we can identify them in the beam component table on the right side of the underlay. For the primary structural framing, we should select RC beam, rectangle, 35 by 65 centimeter, and for the secondary structural framing, we should select RC beam, rectangle, 30 by 50 centimeter. After we model the beams in 1F, the next step is to construct the slabs enclosed by the structural frames. The procedure of constructing the slabs in 1F is the same as the way we construct the slabs in B1F. However, we should be careful about that the slabs in 1F have different elevations. We can identify this by the elevation marks on the underlay. Although these slabs are marked with the elevation symbol +0, the elevation should be set to the ground level, which is -20 centimeters. Therefore, when we construct these slabs, we should set the value of top offset to -20 in the Properties palette. Besides the three slabs, all other slabs have the same elevation symbol +20, meaning that we can set their top offset to zeros. In the next step, let us model the columns in 1F. According to the underlay, there are 12 columns in 1F, and their locations on the floor plan are the same as the B1F columns. Therefore, we can use the Copy to Clipboard tool to duplicate these columns from B1F to 1F. Open the floor plan of B1F. In the drawing area, hold the Control button and then select the 12 columns that we want to duplicate from B1F. Under the Modify tab, click Copy to Clipboard. In the Path Tools drop-down menu, select the Align to Current View tool. Now we can go to the floor plan of 1F to see the columns in 1F. In the next step, we will model the walls for 1F. The steps are the same as what we did for the walls in B1F. Under the Architecture tab, select Wall Architecture and edit the parameters in the Properties palette. We set base constraint to 1F, top constraint to 2F, and keep both top offset and base offset as zeros. With these parameters, we can now proceed to construct the walls. While constructing the walls, we should be aware of different wall heights because not all of the walls reach the level of 2F. For example, the height of the parapet around the planter box is 105 centimeters. In this case, we set their base constraint to 1F, the top constraint to unconnected, and the unconnected height to 105. After the wall construction is done, we can go to the 3D view to browse the results. In the Properties palette, check Section Box and adjust the boundaries of the section box. We can now see the complete structural columns and RC walls in B1F.